Here's part 2 of your Pre-Calc 10.1.2 lecture. I don't want to skip all the very interesting and cool parts, so I do want to read part in your book on 10-16, where it is saying, well, I think I already told you this vocabulary. These are called the major axis is the one that has the vertex, and the minor axis will have the covertex or covertices. The major axis is the one that's going to have the focal points or the foci. I wanted to read this part. It says ellipses also have unique geometric properties. Not every oval is an ellipse. To understand the geometric properties of an ellipse, imagine a pool table in the shape of an ellipse with only one pocket, located at one focus. If you place a ball on the other focus and hit it in any direction, it will bank off the rail and go into the pocket. Also, no matter where the ball hits the rail, it will always travel the same direction before reaching the pocket. This idea has been applied to create whispering galleries, which are in the shape of an ellipse. If two visitors stand at one focal point and one visitor whispers, the other visitor can be heard by the visitor standing on the other focal point. So that's, I found that pretty interesting. You can go on YouTube and just do some searching if you want to find out more about the properties of an ellipse. Pretty interesting. I'm going to go ahead and walk through some of this. This is where you were supposed to derive the equation of the ellipse, but I gave it to you. So this is H and K, A and B. Well, I didn't really make it explicit what A and B are. A is the distance from the center, like it's in the horizontal direction from the center to the vertex. And B is the distance from the center to the vertex in the vertical direction. So from here to here is A. Now there's another distance called C, and that's from the center to the focus, or to the foci. Okay, so I don't know if I mentioned that. So you were going to use this whole thing to derive the equation, but I kind of just gave it to you. Let's go look at eccentricity. So it turns out that eccentricity is something that we use to kind of describe how round something is. So eccentricity, well, let's just read what it says. It says, look at all of the ellipses created by your team. So ellipses can be long and skinny. They can have a horizontal or vertical orientation to them. This roundness is described by the eccentricity, a term that refers to the measure of the shape of the ellipse. Eccentricity can be calculated with the formula E for eccentricity equals C over A. And remember, C, we just now told you this, C is the distance from the center to the foci. Okay, that's C. So C divided by A, which is all the way across. C divided by A. That is how you can get the eccentricity. So eccentricity is always between 0 and 1, because the distance, because the foci are going to stay inside the ellipse, so the distance from the center to the foci is always going to be shorter than the distance from the center to the edge, right? So this is always going to be like a fractional number. Let's see what else it says. Eccentricity can be calculated with this formula, where C is the distance from the center to the focus. Try to keep that in mind. And C squared equals A squared minus B squared. And then that one gets me a lot of questions, because people like to say, well, I know A squared plus B squared is C squared. C squared is A squared minus B squared. And why is it a squared minus b squared, not a squared plus b squared? Well, remember that the total distance, remember I was calling, like, I was saying D1 and D2, and I had that, where did it go? Remember I had this thing, and I was saying that the length of this string, the sum of D1 and D2 is 2a. So if I put it like this, then half of the string is here. I mean, because these distance, D1 and D2 aren't always going to be the same distance. Like, I can tell this D2 is shorter than D1 right now. But if I put it in the middle like this, then D1 and D2 are equal. And so this right here becomes the hypotenuse of a right triangle. Yeah, it's a hypotenuse. And isn't this A? Because if the whole string is 2A, then this piece is half of the string because of the way I've positioned it so that half of the string's on the left and half's on the right. This is A. And then what is this? This is B, isn't it? It's the distance from the center to the top. That's B. And then what's this? This is from the origin, sorry, not the origin, from the center to the foci. That's C. So that's why I'm saying, they're saying C squared plus B squared equals A squared. Or actually what they're saying is C squared equals A squared minus B squared. That's where this comes from. Okay? So you're going to have to memorize that, or just, think really hard about this picture. I would just memorize that, because you're going to need that to be able to find out, like, sometimes you know what A and B are, but you don't know what C is, and so you can use A and B to find C, or maybe you know what C is and you need to solve for one of the other variables. Okay, so that's what this is saying all right here. Then it says go ahead and use a ruler. Well, I kind of already showed you with my little string there, and then I'm going to just take the very last bit of time that I have to help me sketch a graph. Label the vertices, the co-vertices. Okay, so I think you might be able to do this pretty easily, but let's do this one together. So it would be x squared over 16 plus y squared over 9 equals 1. Okay, so now I already told you this is a squared and b squared, and so we kind of already talked about that. So the center, this would be x minus h and y minus k, but it hasn't been shifted right or left. So the center is at the origin. Here's y and here's x. And so the square root of 16 is 4. So square root of 9 is 3. So there's my ellipse. But they don't just want that picture, they want the vertices, the co-vertices. So what are the vertices? These guys are the vertices. Vertices are, I guess it would be 4, 0, negative 4, 0. The co-vertices, where should I write this? Are 0, 3. I guess I could use a plus or minus. That would be okay too. And 0, negative 3. So there's the vertices, there's the co-vertices. What else does it want? Locate the focal points. So now I'm going to have to find out C, like how far, what's the distance between the center and the foci. So I think we have to do that. C squared equals A squared minus B squared. Well, I can grab a and b off here. I know if this is a squared, then a was 4. So actually, so yeah, I can just go 4 squared is 16. 9, or 3 squared is 9. Ew. I think c is the square root of 7. Sorry. So, and square root of 7, I didn't think I'd need my calculator today. Let's see. Let's just see what that is. The square root of 7 is about 2.6, 2.6-ish. So if I wanted to draw it on my graph, it'd be like 1, 2, 3, so 2.6. So it's right in there. I'm going to keep calling it root 7, but I know that it's somewhere between 2 and 3. Okay, so where are my foci? I'm supposed to say where they are. So this one is root 7, 0. And that one is negative root 7, 0. You're welcome to use plusy minuses if you want to. We'll look in the answer book and see. Let's see if they put plus minus on it. Oh no, they separated it too. They separated it out just like me. We're doing good. We're getting them right. Let's see what's next. So yeah, you thought we were just going to graph it, but we got to be careful and answer all their questions. Label the major axis and state its length. Oh, okay, so this one, the longer one is the major axis. Its length all the way across would be, well, it's 4 and 4, that would be 8. And then minor axis, its length would be 6. What else do they want? I think that's it. We didn't have to do the eccentricity, huh? Okay, so if you did want to do the eccentricity, you would go C over A. So you find out what C is. C, we found out it was root 7, and A was 4, so it'd be root 7 over 4. Okay, that's it. You're going to do the rest of them on your own, and then you can ask questions next time I see you.